Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video, we're going to introduce radians. So far in our previous trig videos, we've talked about angles that are measured in degrees. Another measure of angles is radians. That's very useful in applications. I want to talk in this video about what a radian is and how we can convert angles measured in degrees to angles measured in radians and convert radians back to degrees. We're going to start with a circle that has a radius equivalent to r. If we were to take the radius and rotate it in a counterclockwise direction until the length along the circumference is equivalent to the radius. So when that length along the circumference is equivalent to the length of the radius, that amount of rotation is called a radian. And it doesn't matter how large or how small your circle is, it will always be the same amount of rotation. So one thing that you would have learned previously is circumference of a circle. And I just want to review that because it might help you understand radians a little bit better, or at least understand the value. So we know that the circumference of a circle is 2 times pi times the radius. So the distance around the whole circumference of this circle is 2 pi r, or in other words, there's 2 pi of those lengths there. Similarly, when we think about the amount of rotation, just like there are 2 pi times the radius in a circumference, the total distance around a circle, there will be 2 pi radians in one revolution. Which means there are 2 pi radians in 360 degrees. So that's the relationship between radians and degrees. We could divide both sides by 2. Another way to think about it is there are pi radians in 180 degrees. So we know in a complete rotation, there will be 2 pi radians. It's also 0 radians when we start. In 180 degrees, there are pi radians, which means that in a quarter of a rotation, there will be pi over 2 radians. And in 3/4 of a revolution, there will be 3 pi over 2 radians. And those are going to be important values to remember when you are working with radians. Those are the values on the axes. So if you want to know what a radian actually measured, approximately in terms of degrees, we could divide both sides by pi here. So 1 radian would equal 180 degrees over pi, which is approximately 57.3 degrees. So that's what a radian is equivalent to in terms of angular measure. We think of radians, when we express angles in radians, it's actually a ratio, and therefore we don't need units. So whenever you're dealing with angles and you know it's an angle and they don't say what the unit is, understand that it means radians. So for example, if you were asked to find the sine of pi over 4, you'll see it written like that without radians expressed. And we're to understand that it does mean radians. So whenever you have a trig function and then a number following it, we understand that it is an angle. If it's degrees, we do have to use a degree symbol. If it's a number without any kind of symbol, we understand it means radians. Let's take a look at some examples of converting angles from degrees to radians and radians to degrees. If we had our angles in degrees and we wanted to change to radians, remember that pi radians is equal to 180 degrees, and we're going to use that in a process called dimensional analysis to do the conversions. I don't like using that 57.3 degrees equals 1 radian because that's an approximate value. This is exact. So if I am changing from degrees to radians, the idea with dimensional analysis is you multiply by a fraction where the numerator and the denominator are equal so that you have a value of 1 and you can multiply by 1. And when you're converting from degrees, you want to cancel the degrees, so you'll put degrees in the denominator. So 180 degrees is equivalent to pi radians. So the degrees will cancel. And when we are converting to radians, we try to keep it as a neat fraction in terms of pi rather than writing it as a decimal value. It's not always going to be possible, but in this case it is, because I can cancel. 45 goes into here once, 45 goes into 180 4 times. So this will be equivalent to pi over 4 radians. And I'm going to write radians just so that there's no confusion. Let's try the next example. Again, I'm going to use my process of dimensional analysis. As long as these are equal, I can multiply by that fraction, because if the numerator equals the denominator, I'm multiplying by 1. You could use 2 pi and 360 if you chose, but it's just a little larger numbers than is necessary. So again, my degrees will cancel, so my answer will be automatically in radians. 30 goes into 30 once, 30 goes into 180 6 times, so my answer will be pi over 6 radians. Next example, same idea. Degrees cancels. I can reduce this. 30 goes into 150 5 times. 30 goes into 180 6 times. So when we can write our angle as a nice fraction in terms of pi for radians, we do that. In this example, I'm not going to be able to. Because we have a decimal here and we're not going to be able to reduce this nicely. So when you have a situation like this where it's not going to be a nice fraction, then I would just use my calculator and multiply 25.2 times pi, and then I would divide by 180, and I would get a value of 0.44 radians. So that's how you could convert if you were asked to convert from degrees to radians. Let's look at going the opposite direction. Again, I'm going to use the fact that pi radians is equivalent to 180 degrees and dimensional analysis to convert these. So if I had pi over 3 radians and I wanted to convert that to degrees, I would multiply by a fraction. I want to eliminate radians, so radians goes in the denominator, degrees goes in the numerator, and then I have to write an equivalent value in the numerator and the denominator. So I know that 180 degrees is equal to pi radians. So radians, the unit radians will cancel, and pi will cancel. I'll have 180 over 3 degrees, which is 60 degrees. Next example, same idea, 3 pi over 4 radians. So I'm going to multiply by 180 degrees over pi radians. You'll always know what order by looking at what unit you want to eliminate. That needs to go into the denominator so that it will cancel. Pi cancels, and I've got 4 can go into 180 45 times. 45 times 3 is 135 degrees. Or you can multiply 3 times 180 and then divide by 4. Sometimes you will see an angle in radians that's not expressed in terms of pi. We're still going to do the same conversion. I want to eliminate radians, so I'll put pi radians in the denominator so that the radian unit will cancel. And then I'm just going to take 2 times 180 degrees and divide by pi. So in this case, we'll need to use our calculator, and we should get 114.6 degrees. So that's how I would convert from one unit to the other. I would avoid using that 57.3 just because it's an approximate value. And then you're not going to have your exact values for some of your angles in radians. So practice converting back and forth. And what I would like to do in the next video is show you how to find your trig functions and inverse trig functions when your angles are in radians. So take care, and we'll see you on the next video.